sure we can get this in. Okay. See if I can expand this a little bit. Can I? Oh yeah, I can expand this. Beautiful. All right. Whoop. Oh no, I don't want to. Options. Sorry, give it a second. I guess not. Oh, I guess it might be okay. All right, well, we'll go back. So, okay. Well, something's wrong now here, because now, let's see if I can flip this. Okay. Oh, it's not working. Shoot. All right, I'm gonna probably then make another video. So, no, it should work. I've done this before. Let's see. Maybe I just capture it. Let's see now. Okay. Oh, if I press exit. Okay. All right, I think I got it now. Yes, there we go. Okay, so inside your notebooks, you already have the title 3.1 through 3.2. And there are many types of mathematical relationships between two quantities. So another example of this would be a scoring system. Is anybody on a track team? Well, I would have someone read. In a scoring system of a track meet, first place is worth 5 points. Second place is worth 3 points. Third place is worth 2 points. Fourth place and fifth place are both worth 1 point. Because there are so many events, and the winning team can be the team that got the most points, even if not everybody won first place, you could still, whole team could win. Okay, you could take this system and represent it as a set of ordered pairs. This 1-5 could stand for first place, 5 points, right? And this 4-1 could say fourth place is worth 1 point. There are also other ways to show relationships, such as tables, graphs, or something called a mapping diagram. And we're going to take a look at some of those right now, right? So, let me see. I don't know if I can move that. Oh, no. Can I get it to be wider? Okay. Nope, it won't go wider. Sweet. Zoom out, maybe? No. Okay. So this could be maybe possibly the, it could represent in a table, which is a little bit nicer. It tells you the place and the points. Some of mine's cut off. You could see it as a graph, like so. Or you could express it as a mapping diagram. And that's what I want to teach you right now. So inside your note, I'm going to take a different set of points, 1, 3, 2, 4, 3, 5, 3, 4. And we're going to express it as a map. So what we do when we have relationships, we have two categories a lot of times. We have inputs and we have outputs. And you've seen this in the past. So what we're going to do is our inputs, we're going to put all our x values. Input is x. So our x values for these ordered pairs are 1, 2, 3, and 3. And we're just going to put that in, 1, 2, 3. We're only saying what the inputs are. And we're not going to repeat the 3s. We're going to say 1, 2, 3. Okay. Then in the output, you do the y values. So what are the y values we have? Well, we have 3, we have 4, we have 5, we have 4. So we're only going to put down what we have. Well, we have a 3, 4, and 5. Okay. Now, the last step is to express it as a mapping. Right now, so to map it, what we're going to do is identify which input goes with which output. So 1, we know, is supposed to go with 3, so we do a little line to it. Hey, 1 goes with 3. 2 goes with 4. Now 3 goes to 5, but also goes to 4, so how do you think we handle that? And I usually take an answer, and maybe you know. Well, we just go 1, 2. Boom. We've created a mapping. We've said that, It tells you where the inputs go with which outputs. And there's your mapping. Sweet. Okay. So every relationship has something called a domain and a range. And this is where I want you to add some stuff. So this relationship has a domain and range. And this is where we're going to add it. Our domain is another word we use for input or our x values. And the range is another word that we use for outputs or y values. So we're going to interchange these: domain, input, x values, range, output, y values. These are all going to be connected. So above the two tables that we have wrote input and output a second ago, could you put the word domain above the input word and the range above the output? And that also gives you information about the domain and range. Okay. Questions about domain and range? You may or may not have heard those words. I know last year was a confusing year, but we're using them now. Everyone repeat after me. Domain. Okay, say it again. Domain. All right, repeat after me. Range. Range. Okay, repeat after me. Range. Range. And so we're going to interchange all these, and I'll keep reminding you. Range, outputs, y values. Domain, input, x values. Okay. So if you're taking notes, we're going to write down 3.2. And this chapter is really focused around something called functions. So many relationships are also called functions. So repeat after me. Functions. Get recording here. Slide this up. Sorry, guys, I'll be right back on that recording. Okay, sorry, I'm back. So many relationships are called functions. So repeat after me. Functions. Functions. So repeat after me. Functions. Sweet. Okay. A function is a special types of relationship between two quantities. You don't need to write this down yet. Okay? I do want you to write this down. A function, each of its input values, domain, gives back exactly one output. So read it yourself. Each of its input values gives back exactly one output value. Each of its input values gives back exactly one output value. So, and that doesn't make sense so much, but this is the important part. We study functions because the ultimate power are their predictability. Ultimate power are in their predictability. So we're going to spend a lot of time studying functions because they are so predictable. All right. But let's kind of explore that idea really quickly again, that each of its input values gives back exactly one output value. And like what that means. Okay, I don't know if you knew this or not, but most vending machines actually hide a function. I know. Take, for example, a Coke machine or a soda machine. It's actually a function. Each of its input values gives back exactly one output value. So, the question is, why is this vending machine a function, right? Well, why is it? Does each input give you back one output? Forget the money, because money you have to get them all. But what do you input and what do you output if you want to get something? Say if you want to get the Coke, regular Coke, what do you need to input after you input money? You have to input the button, right? And when you push the red button, you want to get Coke. If you push the green button, you want to get Sprite. So the red input gives you back the output of Coke. And the green Sprite gives you back the green button gives you back the output of the Sprite. The green button gives you the Sprite. Okay, this is important. So because it is a function, we can say that the soda you get is a function of the button you press. Okay, and I want you to write that down. The soda you get is a function of the button you press. And that doesn't ever make sense to me. I've taken a lot of math classes, and I'm always like, what? The soda is a function of the button you press? So long ago, I decided to switch out is a function of. So let's read the second sentence. We're going to sub out is a function of what depends on. Let's see if it makes sense. The soda you get depends on the button you press. Does that make more sense? And the answer is yes. Obviously, the soda you get depends on the button you press. But that also means the soda is a function of the button. And that's confusing. So we're going to see me switch out is a function of and depends on to make it make more sense. Okay? And because this is a function, it has a domain. What is the domain? What is the range? Well, the domain are all the inputs, right? All the buttons. And the range are all the sodas and waters and stuff you can get out. Hey, Mom, I'm just teaching right now. Can I call you right back? I'm recording a lesson. Can I give you a call back right after this?
Yeah. Yeah. I fell asleep. I just woke up.
Okay, bye. Okay, all right. So here we go. You ready? This vending machine, it doesn't really exist, but this one doesn't hide a function. I made this one up. So here's what it is. How this one works is if you press the yellow button, you can get one of 4 sodas. And if you press the green button, you get one of 4 juices or water. So let's go back to the idea of function. Each of its input values gives you back exactly one output value. All right, so why is this vending machine not a function? Why do you think the way this works, it's not a function? If a function is each of its input gives you back exactly one output. And I would ask you to turn and talk to your neighbor for like 10 seconds and have a discussion. Why isn't this a function? And then someone would share out. And then I would say, yeah, because you can't predict what drink you're going to get. This is not a function. Functions are predictable. Each input gives you back exactly one output. If you press the yellow, do you know if you're definitely going to get the Coke? Maybe you only like Coke. Are you guaranteed to get Coke? No, because you're going to get one of these 4. Maybe you hate the other options. Or you really want a red Powerade and you press that green button. Are you guaranteed to get the red Powerade? Does that input only give you the one output? Well, no. But it still has domain and range, even though it's not a function, because it's a relationship. We got our domain, which is reduced to yellow and green. And our range is the same. Okay. So you don't have to write anything down. But the question is, what does predictability of a function look like in a table? Okay. So each of its input gives back exactly one output. This one is a function, this first one. The second one is not a function. Look at the definition and talk to somebody. Why is this first table a function and the second one not a function? So I'd have you turn and talk to your neighbor and you guys would discuss what makes this a function and this one not. And then someone would share out and say, well, this is a function because each input only has one output. I said, but 1 gives you 7 and then 1 gives you 7. And someone would be like, yeah, well, the input of 1 gives you 7. I'd be like, great. So why is this not a function? And a student would say, well, 10 gives you 15, but then later on, 10 gives you 55. So this, the input of 10 has two outputs, and that is not a function. That's like pressing the red button and getting Coke, and then pressing the red button and getting a Sprite. That's not predictable. We want to know what we're going to get. Oh, it slipped. That should be up. That should be up there. Anyways, okay. How can you tell if a relationship is a function from a table or a mapping, right? So, wow, this shot shifted up. All right, so again, take a look at this table. Is this table on the left a function? And is this mapping a function? Now, they both could be functions, they both could be not functions. Talk to your neighbors, see what they think. Which one, each of its input gives back exactly one output. And people would talk, and then I'd share out, and I said, what about this first one? Who has an answer? People would raise their hand and say, the first one's not a function. And I would say, why is this first table not a function? Well, the x's, which are the input, one has two outputs. I'd say, yeah, the one has two y values. It has both -5 and -2, not a function. And then I would ask you about this one. Is this a function? And people would be like, yes. And people are like, no, that's not a function. And people are like, yes, that's a function. And be like, no. And I'm like, okay, who's on the function side? Who's on the non-function side? And one person would be like, I think it's not a function because 2 goes to 1 and -3 goes to 1. And someone who thinks it's a function would be like, that's okay. 5 goes to 4. 5 always goes to 4. 2 always goes to 1. When you touch 0, it always goes to -2. And -3 goes to 1. So that's okay. Each input has exactly one output. And, think about our vending machines at our school. When you press the first button, it gives you water. When you press the third button, it gives you water. When you press the fifth button, it gives you water. That's okay. Different inputs can have the same output. Okay, so our homework is that the stuff I put up here, let me see if I can jump to it quick. Okay, so take a moment. I think we're late on class. So this is finished for classwork, finished for homework, and then we'll come back and talk about the next lesson. Okay? Go back here, right back in. Yeah. Okay.